Welcome, Fact Finders, to G Fun Facts Online, your go-to source for the most intriguing tidbits from the world of science and technology. Today, we're diving deep and then walking right out of the water into the amazing world of amphibious robots. Imagine a machine that's part Land Rover, part submarine. That's an amphibious robot for you. These aren't just science fiction. They're real, engineered marvels designed to conquer both solid ground and watery depths. Why is this so cool and, more importantly, so vital? Well, picture this: a robot that can seamlessly search for a missing person along a rugged coastline, then plunge into the waves to continue the search underwater. Or think about environmental scientists needing to monitor a delicate shoreline ecosystem, both above and below the waterline. Amphibious robots make these challenging tasks possible, but building these versatile machines is no walk in the park, or swim in the lake for that matter. Engineers face some seriously tough challenges. First off, the obvious one: waterproofing. You've got sensitive electronics, motors, and all sorts of delicate parts. Keeping water out, especially under pressure, while also preventing rust and corrosion, is a massive hurdle. It's like trying to build a high-tech computer that you can confidently throw into a swimming pool. Then there's buoyancy. How do you make a robot that can float when it needs to, sink when it wants to, and stay stable in the water? It's a delicate balancing act, often involving special lightweight materials or even tiny ballast tanks, like miniature submarines have, to control whether they float or submerge. And what about moving? Hopping from land to water means you need different ways to get around. Wheels or tracks are great for land, but not so much in the water. Propellers or water jets excel in aquatic environments, but are useless on the beach, so designers have to get creative. Do they use separate systems? Or can they make one system adapt to both? It's like trying to design a car that can also swim like a speedboat without compromising on either. Perhaps one of the trickiest parts is the transition itself, that moment of going from land to water, or water to land. Think about an unstable, muddy riverbank or a rocky shore. The robot has to handle that change smoothly and reliably. It's a real test of engineering grit. So how do these amazing machines actually move in these two different worlds? Engineers have come up with some brilliant strategies. Many amphibious robots use a classic combo: wheels or tracks for land, and then propellers or water jets kick in once they hit the water. Sometimes those wheels even retract to make them more streamlined underwater. Then there's the bio-inspired approach. Some robots mimic nature. Think of legged robots, like mechanical crabs or salamanders, that can scuttle across complex terrain and then use those same legs to paddle or wade through shallow water. We're also seeing robots that move like snakes or turtles, using body undulation or flapping fins for both crawling on land and swimming gracefully in the water. These can be super stealthy and maneuverable. And for the truly futuristic, there are transformable robots. These are the shapeshifters of the robotics world. Imagine wheels that fold and change into paddle-like structures, or fins that deploy from the robot's body when it enters the water. How cool is that? Building these robots to be tough and reliable is key. Designers often use modular components, so if something breaks, it's easier to fix or upgrade. And they spend a lot of time thinking about stability. You don't want your expensive robot tipping over during a crucial mission, especially when it's moving from land to water, where the forces acting on it change dramatically. The field of amphibious robotics is rocketing forward. We're seeing soft robots, made from flexible materials, that can squeeze into tight spots or absorb impacts. Artificial intelligence is making these robots smarter, allowing them to learn and adapt their movements to new environments on their own. Scientists are even exploring ways for these robots to harvest energy from their surroundings, like using solar power on the surface, to extend their missions. And get this, they're getting smaller. Miniaturization means we could soon have tiny amphibious robots exploring places humans and larger machines can't reach, like inside pipes for inspection or tiny crevices in disaster zones. The future looks incredibly bright, or perhaps I should say incredibly versatile for amphibious robots. These aren't just gadgets. They're becoming essential tools for exploration, rescue, research, and industry, tackling some of the most challenging environments on our planet, and maybe one day, beyond. That's all the time we have for today on G Fun Facts Online. Join us next time for more amazing insights. Until then, stay curious.